Welcome all. So we start our webinar now. Vignan, over to you.
Sure. So this is Vignan Malyala. You can see my LinkedIn link if you want to connect with me. Connect there. Sorry about my voice. A bit cold here and having the cold, but anyway, I'll cover it up. So today's agenda, I'll be discussing on the code Llama, which was released recently on August 24th by Meta. So agenda will be firstly I'll going through the understanding of code Llama paper and also explaining the architecture, how it was trained and what are the infilling points they've used. And later on, we'll also try to use it live, explore some examples, and then implement the same thing using Hugging Face transformers and try different completions on code Llama, code completions on code Llama. Right, and that's the agenda. Yeah, let's start with so code Llama is a large language model, and it's mainly used for text and code generation. It is trained on Llama 2, so it's not trained from scratch. It's an enhancement from Llama 2. That's where Meta has implemented code Llama with a recent launch. Okay, it has a good potential, and the productivity is there to help programmers and even educational students in the educational tool to write well robust documented software. That's the primary idea behind why they built it. It can generate code, natural language about the code. It can be used both in code and natural language prompts. You can write both prompts with respect to text and code. Like if you write an example, write me a function that can output Fibonacci sequence, so it can understand that and give the proper code. So that is the primary advantage why programmers and students can use it as a tool to write good software. Okay. Apart from that, it supports a lot of, most popular programming languages which we use today in the daily world. Primarily Python, C++, Java, PHP, TypeScript, JavaScript, C#, Bash. These come in the major range and a bit of more. But primarily, they say that Python, C++, Java, JavaScript. So these are C#, Bash. These are very much popularly used, and the model is trained with. That's where the common language comes into usage, right? So as I said, it's also free. It's also free to use for commercial usage. You have to just request. If you want to use it for commercial usage, you can just request a mail going to ai.meta.com and then request for the model, and they'll send you a link out. And then in the GitHub, there's a link. There's a bash file, download.sh, which you can run. When you run that file, it will ask you to paste that link which you got in the email. If you paste that link, you can select the number of models you want to download, and it will download in the local or maybe in the GPU. Okay, to train on a large data, you can use A100 GPU, which is commonly used to train your model on the large data. Recently, Snowflake was trying to do that, and they have implemented text to SQL model, and they have seen that it was quite better than GPT-4 as well. Okay, Llama 2 and obviously Llama 2 also. So Code Llama was quite better on fine-tuning on text to SQL compared to GPT-4. That's what Snowflake even claims. I'll show the results maybe in the next slides. So if you want to use it, you can use it commercially and download it with the link and the GitHub repository. Okay. So Code Llama has 3 variations, unlike Llama 2. So it's having 7 billion, 13 billion, and 34 billion parameters. And it has 3 variations. One is Code Llama foundational model, and Code Llama Python model, and Code Llama instruct model. So foundation model, we can use it for generic tasks. When I say generic task, you can use it. You can even use for text classification, sentiment analysis, language translation. But code is being an advantage. You can use it for specific tasks on code like SQL, code training and all. right? So because code is advantage, but you can also use for other models. That's the foundational model. Code Llama Python, it is recommended to use on specific tasks, not on a generic tasks, and primarily with a good choice of Python, interface in it. Okay, and Code Llama Instruct. So this is again something called with user assistant type of instructions they have trained on. So it's simple and intuitive way how the model and hyperparameters are implemented here. And so it's you can use it as an interface where you can request maybe like a chatbot, or implement like a chatbot in the real time. Okay, so more of mix of natural language and text. So the example which I will be showing in the next slide, yeah, this is kind of an example for Code Llama Instruct. So the
No,
prompt
I
is,
had a question actually, Sai. So on this slide. So can this use for coding specific GenAI tasks, or can it also be used as a general chatbot like Core Llama 2 or ChatGPT?
yeah, it can be used in the both fashions. The both fashions.
Okay.
You can fine tune it as well. As I was saying, Snowflake was trying to do text to SQL, and only for the code, and also as a chatbot with the code. Or if you don't want code at all, you can use for text classification. Why? Because it's trained on Llama. So Llama 2, the 2 trillion tokens which it has been trained on is already infilled in Code Llama.
So
Okay?
Llama has 2 trillion parameters. Llama
Not
2
parameters, 2 trillion tokens, I would say.
tokens. Okay.
2 trillion tokens, and
Hmm.
Code Llama is 500 billion tokens.
Now, if let's say in Imagine GPT, we are implementing Llama 2 based app. So we are giving the GPT for cloud API option, but many customers want privacy, right? For keeping their data within a private cloud. So we are also proposing to offer Llama 2 based chatbot in Imagine GPT for all of our apps there. So should we go with Code Llama, which has chat plus coding capabilities, or we should stick to Llama 2 and keep Code Llama exclusively for coding tasks?
Okay. So Llama 2 was trained on 2 trillion tokens, I was saying, right? So in that, 15% of which is only code, the rest of 85% of the thing is just text, NLP text, right? So that is where Llama 2 stands. Okay. Code Llama is having the 2 trillion as it is, plus it is also trained on 500 billion code tokens, and in that 500 billion, again it says 15% for text. I mean code text. I mean, like, you text which is related to code, like, you write some explanation for the code comments or something, right? So in that fashion, so in 500 billions of code tokens, in that 80% is code and 15% is text in understanding to code. So that is how Code Llama stands. So if you want to have code as your primary understanding for the end user to train, Code Llama is the best. But if it is not the priority, then Llama 2 is sufficient. Is that clear?
Yeah, that answers. Thank you.
Correct. Okay, so we are at these 3 variations. So you can choose a model accordingly which you want to use as per the definitions. Generally, the foundational model is good for the generic tasks. If you want to instruct or maybe fine tune based on language or the chatbot way, you can choose the either of these 2. Okay, and
Harish was raising his hand. Harish, you had a question?
Yeah, so I'm basically pretty new to this LLM thing, but I have one curiosity that if consider this 7 billion model Code Llama, what is the cost and time perspective measurement if we have to train that and make it usable from cost point of view?
okay, in the cost point of view, right? So in general, the 34 billion model returns the best results, as per their performance stats. Okay, and it allows for better coding assistance. It is it's actually better than GPT 3.5, and but not as good as GPT 4. The 34 billion model, but obviously it has that latency. But however, the 7 billion and 13 billion models are faster and more suitable for tasks that require low latency, like real-time code completion and all. So these 7 billion and 13 billion are fine in terms of latency. But if you want this 34 billion, it's good in accuracy, but not as good in latency unless you have a good highly powered 800 RAM or GPU RAM or something. Right.
So basically, cost will be depend on in which GPU model will be running this model, right?
Yes, it depends on the GPU model. And in fact, no, you can also use something like replicate.ai if you heard of something like that. So I mean, in general, we know that GPT, the OpenAI, the charges based on tokens, right? The charges number of the cost based on the tokens. But here there is nothing like tokens. The cost is not based on tokens. It is it's open source, so you can deploy it in your own system, and you can use as the pay as the hour or minute or seconds. So there's a website like replicate.ai. There are many websites, but this is the one which I used, where they fit this model in their GPUs, and you can use them as needed, and they'll cost you per second. Right. So that's the costing is similar to the token cost, if I say. But if you want to deploy on your own system without any leakage of data or something, then it will cost you quite high if it's a bigger model. But for 7 billion, 13 billion, it will not cost so much. Even AWS ML6 is fine for 7 billion, 13 billion model. If you use the SageMaker ML6X is fine.
Yeah. Thank you.
Yeah, I think Neeti has a question.
Hi. So even I am a bit new to this, so I understand that these models are available, released by Meta, and available for free use and commercial use as well. But if I want to particularly use it on individual basis, then I can either install it on my machine, but if I want to make it available for someone, I will need a GPU support, right? So how is that possible? Like, because we as an individual cannot host or buy GPU or have a data center. So how do you propose to do that?
Yeah, I was just mentioning. So you can use AWS, SageMaker versions and all. So that you'll get the required GPU RAMs and all.
Okay.
If you want to go with a higher, if you want to go with a higher RAM and you have a lot of hits and all, so higher GPU is fine for a bigger model. So,
Okay, but that does not have a risk of data leaking, no? The security will be with us only, even if we use AWS GPU.
yeah, the AWS cloud, which you use in general for all your, all your data tasks and also in a similar fashion.
Okay, understood. Thank you.
Yeah, you can, just to augment that answer a bit, so you can try our client's product freedomgpt.com. We are the development vendors for this product, and here we have developed a laptop runnable Llama 2 chatbot. You can download it on a Mac or Windows computer. It's a full Llama 2 model which will run entirely locally on your Windows or Mac laptop in total privacy mode. So so that is an edge AI as we call it. So it's a laptop edge. And for document mining, you can try our product, but currently it's on the cloud, and the data is going to email GPT API. So our product is called Imagine GPT.
Okay, so I'm sorry, I missed the name. What was the client name that I should
I
try?
put it in chat, freedomgpt.com. You can download this Llama 2 chatbot, which we have developed for our client completely on your laptop, either Mac or Windows, and run entirely locally. You can disconnect the internet; it will run beautifully on your laptop.
Okay. Thank you so much.
I think somebody else had a question, Ajay.
Yeah, thanks. So as Vignan, you are saying that Code Llama is a fine-tuned model on top of Llama 2, right? So when we do fine-tuning, right, there is a problem of catastrophic forgetting. That means that when we fine tune on something new, the old things we tend to forget. So does Code Llama also has this problem, like, or does it did it tackle it with something?
I mean, yeah, catastrophic forgetting, fine tune. I mean, that's the CF. That's in general. No, I mean, the model forgets. No, so I mean,
Yeah.
just overview. So it is just that the model forgets the previously learned information as it learns new information. So that is what uh, uh, happens. Even in the LLMs it happens. So, however, this I mean, in general fine tuning, this happens, but I'm not sure of Code Llama because they haven't mentioned anything on this part. So maybe their data was quite different.
Yeah, true. In the paper, they never mentioned about this catastrophic forgetting. Yeah, that was curious. Okay, thanks, Vignan.
Okay. Yeah. So going next. So in this, so this was an example for Code Llama instruct. So here you have the prompt and you have the response. How the response comes in the fashion. Uh, it gives you the answer and also what everything in the answer means. I mean the description of the answer. So that's how Code Llama instruct works. Different than the foundational model. Okay, so this was just the bash how to list all text files in Terra directory. Right? Yeah. So how it is trained? So as I'm saying, it was trained on Llama 2, and Llama 2 has 2 trillion tokens, and the Code Llama has ingested extra 500 billion tokens, which is core and core related data. So code plus code text. Okay, and the data is tokenized using byte pair encoding, which is also the same tokenizer of Llama 2. So it's basically the same tokenizer of Llama 2 they have used to even tokenize the data. So byte pair encoding is again a method where you merge most frequently occurring pairs of characters or bytes into single token. So until you reach certain number of tokens or backup pair size, so you get that most frequently occurring pairs, and then you you chunk it to a single token. Okay, so this way of doing tokenization helps majorly in improving the performance of NLP tasks and also handle. The advantage is mainly handling rare and out of vocabulary words. So that's where BP is popular, and even Llama 2 and Code Llama are using the byte pair encoding, which is, I mean, the same tokenizer for Llama 2. And Llama also, not just Llama 2, even Llama also is using byte pair encoding. And the optimizer they've used is Adam weight decay. And these are the values they have specified in the paper. So Adam is what we know we use in general. So Adam weight decay is the version, the optimizer they have used here. And the capabilities in additional is that the smaller models, the 7 billion and 13 billion models, are not just trained for code completion or text code generation, but also they can fill in the middle. They have the fill in the middle capability. That means you leave information in between the code which is missing. Okay, so it can fill the code in between also, which is not there in 34 billion parameter, and it's not also available in any other models as they claim. So this model has this 7 billion and 13 billion model have this capability that they can fill the code in between, in between as well, so in between the inputs. And so that's an additional capability which is which can be noticed or tried out. And the second advantage is it's trained on 16,000 tokens, and unlike Llama, it is 2048 and 4096. Here it is the sequence was 16,000 tokens, and based on their tests, it is stable even when even the context window is 100k tokens also. Okay. Even if the context window is 100k tokens, still it was very stable. The perplexity hasn't affected even when the tokens have reached 100k, and after 100k it has decreased quite. So they have kept the limit of 100k context tokens, context length. So you can, unlike GPT-4, you can which is 4096 or even Llama, you can try for 16,000 and more in your context. So that's an advantage. We currently have issues of uh, we in the general world we see that we have issues with context a lot, context memory a lot. We use LangChain, we use Llama index to optimize a lot of the buffer memories and all. So that issue will not occur, if you use Code Llama with long context as well. So that's an advantage we can see. And yeah, so the total model additionally has 500 billion tokens, which is 85% code, and 15% is the code text. Based on evaluation with other models, they have seen that it is 53% and 55% accurate on the benchmarks of human eval and MBPP. Okay, so these are the accuracies based on these benchmarks, big benchmarks. And they also say that the Python, Code Llama Python 7 billion outperforms Llama 2 70 billion model as well. So if you want to choose between the code training for a 70, it's called Llama 2 and Code Llama. So Code Llama 7 Python is quite good. Okay, so that's a comparison. Instead of loading your model on 70 billion parameter with a huge size, you can instead use a 7 billion Code Llama Python model. So that will save your RAM, right? Yeah, any questions here?
Yeah, I had one question. So you said that it was trained on just 16K tokens, but how is able to support 100K tokens, because it's just trained in 16K tokens? Because increasing context length is a very big and challenging task, which GPT-4 has also not been able to come up to 100K. Only Claude is able to come up. So the Code Llama, they just got lucky, or like are they doing any innovative stuff, like even though if they've just trained with less tokens, they're able to support more tokens?
It's not lucky. So they have used I think I'll go explain the next slides, maybe.
Okay, cool, sure. You can whenever you come, you can let me.
I mean, here is also the graph. Let me explain this now itself. So this is the context length versus perplexity, a graph. So for 7 billion, 13 billion, and 34 billion. So you see, as it grows after 16K, so even till 100K, it was stable in terms of perplexity. After that, the perplexity increases. Okay, even when there are small after 16K. So this graph, they have seen that has helped them to conclude that 100K context length was stable. And yeah, and apart from that, they have used something called rotational context, which is quite different, which is not used in GPT-4. So that is what they claim that has improved this performance of rotational context. Okay, so I think we have to dig a bit more on rotational context. It's a different paper, but on an overview, this rotational context is the method they have used or employed to help it, to increase the context. Okay. Yeah. And apart from that, regarding the 500 billion tokens, so I said 85% is code, and 8% is natural language related to code, and 7% is natural language. Okay, and in Code Llama Python, apart from 500 billion, they have added extra 100 billion of tokens. Okay, so that is in Python 70%. The other code is 10%. Natural language related to code is 10%, and 10% and 5% is natural language. All right. So the Python Code Llama is not 500 billion tokens. It is 500 billion plus 100 billion. That is 600 billion tokens. And in that 100 billion is specifically in terms of Python and Python text. Okay. Yeah. And any other questions here? If I want to stop sometime.
I have a question.
Mhm.
So when you say Code Llama Python 7B, so is it like it is trained for only for Python coding or all coding language in general? Like what does Python mean here?
Yeah. So I was saying uh, it is this 500 billion, which is Core Llama tokens for 500 billion tokens plus additional 100 billion tokens of Python. That's why it is saying Core Llama Python. So it is a functional model plus Python Python tokens.
Okay, understood. But any particular reason why Python is given the more training as compared to other languages?
Yeah. So they have informed that in the current in current world, Python and the PyTorch, are quite highly being used. So that's why they have used this model specifically for this purpose. So they have mentioned that Python and PyTorch, these two, made the influence and the usage for this pattern.
Mm-hmm. Got it. Thank you.
Okay, and apart from that, I just forgot to mention. So we have also known about the other LLM models for code generation. Like we have Alpha Code, we have Star Coder, which are also famous for code generation in LLM models, right? So even Codex, right? Codex, Star Coder, Alpha Code. So these even Llama 2 as such foundational model. So Alpha Code and Star Coder were trained on code only. There is no text at all. So it's only trained on code, but still they were very good in performance. And Codex and Llama 2 were the two models which are trained on. Uh, I mean, not they're not having the background on just code, but it's fine tuned on general language model like Llama 2, right? So Codex is fine tuned on general language model. So even Code Llama before they were implementing, so they have initialized the model with Llama 2 and not just code. So they have used we have also mentioned that the Llama 2 outperforms perform the same architecture, trained on code only for the given budget. Okay, so it's pre-trained on general purpose text and code data. Okay.
Okay.
So that is the difference between the Star Code or Alpha Code and current Code Llama. Okay, they are trained only on code, but these are fine-tuned on general language models. Okay, that's the primary difference.
And
Okay.
are you also going to cover how to deploy and use this model, like how to program this model to maybe have our own ChatGPT or some other use case?
Yeah, I'll be showing how to use it. Maybe I'll show you this Google Colab. I've used 7 billion Colab with Colab, GPU, TPU. So I'll be showing that, but I'll not be doing a fine tuning. That will cost some time and resources as well. So maybe we'll cover in next sessions. But today we'll cover how to use it on Colab. Right.
Thank you.
Right. So yeah, so this is a architecture on how they have trained. So the Llama, these are the Llama 2 foundational model, 3 different versions, and they have done 500 million extra tokens with code training and infilling code training. I'll explain this too. And then you have Python training, 100 billion tokens, and then there's long context fine tuning, and then you get Core Llama Python. Okay, apart from that, for the different version of Code Llama, so they have code training and infilling code training, and then they have long context fine tuning, 20 billion tokens, and then you get Code Llama. 2 long context fine tuning. If you add instruction fine tuning, you get Code Llama instant. Okay, so that is the primary difference between these 3 versions. Code Llama Python has the Python code and long context fine tuning. So even that's a factor. Someone was asking the question, right, regarding how it's understanding the long context. They have implemented long context fine tuning with the rotating context parameter. So this was the major factor affecting the 100,000 context length as well. Okay. And
I have one more question over here. So does the sequence matters? We do first long context tuning, then we do the the code infilling thing. or we do the instruct fine tuning first, then we do the long context? Does the sequence matter?
Here they have used this version, but maybe we can try. We can try
Yeah.
some other way also. I mean, I think that basically depends on the resources and the decisions you make. Otherwise,
Because we
otherwise the layers are just changeable based on. I mean, in general, you can change the layers here and there, unless you have a specific reason or something. Okay, I mean, in general architecture, we can interchange, but Code Llama, maybe they had the decisions based on their data.
okay.
Okay. Okay. Yeah. So these three, I hope, are clear. So yeah. I mean, so here we have code training and infilling code training. So infilling code training, so it's basically autoregressive training. I mean, maybe it's fine tuning on LLMs for prompt completion. Okay, so that's infilling. So it does not provide the it does not provide the capability to fill a missing portion of text. While you take surrounding context into account. Okay, so here the 7 billion and 13 billion parameters model, Llama models can consist of both autoregressive and casual infilling predictions. Okay, so this will help you, help in the applications like the real-time completion with respect to source code editors or doc string generations. Okay, so in that fashion, it will help you. And also they have mentioned that this infilling code training came at a low cost to them, and they had a huge performance in the complete budget. So they used a character level split, and the cost was also quite less. So this infilling is basically training on the capability to fill a missing portion of text while taking the surrounding context into account. Right. So and it helps you basically in code filling and doc string generations and all. So just to summarize this, and apart from code, and main part is long input context, so which is this long context fine tuning. Okay, so here so you can why this is useful is because you can unlock repository level reasoning for completion of your code or something, right? So in general, the previous models they were opposed to function level or file level only because of the context, but here the long input context can help you to unlock even repository level reasoning. So that's what they claim. Okay, and the prompting of the model is in general 4096 for Llama 2, but here with the proposal of fine tuning with a maximum context length, so it has gone to 16,000 and then 100K. Okay, so as I was saying, so why this was possible is also because of rotational context. So we call it rope positional embeddings. So that is where these parameters of rope help you to extend the context length and learn better. Okay, so that's a different paper on rope, but just to summarize, the rope is the parameter to embed these positions and train on the context length of 100K tokens. Okay, and they have seen that Code Llama, with large context, had huge performance on even benchmarks with 100K, as I was showing the graph, right? So, and the disadvantage is they had a lot of cost for doing this. The cost has increased based on the RAM for the long contexts. Okay, so that's about long context. And thirdly, we have instruction fine tuning, which is only specific to Code Llama instruct. So instruction fine tuning again. So it's fine tuned on a mix of proprietary instruction data, and they call it self-instruct dataset. So they have developed a dataset called self-instruct, which they have just annotated 14,000 question answers. I mean, on questions and answers, only 14,000 with help of human annotators. And then they have infilled this data to Llama 2 and generated 64,000 completions. And then with deduplication, they got 54,000 instruction data sets. And then they have associated this to the self-instruct data set to provide that their unit tests and solutions. So that's how they have used the self-instruct in self-instruct data set, which is a custom proprietary data to train the model. So it's also machine generated self-instruct data set. It's not it's basically human generated first and then machine generated to enhance it, just like augmentation, data augmentation. Okay, and they have seen that this CodeLlama instruct is very good in terms of truthfulness and less in toxicity. So that's what they claim. And apart from that, so it also has RHEL. They have also used RHEL in the later runs to fine tune it. Yeah, so that's about this.
What was the last sentence you just said? They also have
RHEL.
Oh, okay. Reinforcement learning.
Reinforcement learning for human feedback.
Okay. Oh, RLHF. Okay. Oh, you are saying they've used RLHF to fine-tune CodeLlama, or RLHF was already used in CodeLlama 2?
No, they have used it for Llama 2, but here I'm saying they've also used for self-instruct data set.
I see.
For instruction fine-tuning,
Got it.
they had this proprietary self-instruct data set, which is annotated and then augmented and then used RHEL for enhancing it. So that's where this stands in different fashion. So this example which I was showing is CodeLlama instruct. So this is like a question and answer and then the description for the answer. Right. So that's how they have generated a lot of question answers. Okay. Any questions still here? Should I summarize again?
Manually annotated 14,000 Q&A.
Yeah, around 14,000 question Q&As, like user assistant type supervised.
And on top of that, they also did reinforcement learning with human feedback in the loop. Huh?
Yes. And they also augmented it with Llama 2 only. So and then be duplicated as well.
So Sai, can you distinguish very briefly what is short versus long context concept? I mean, I get it, but I'm still trying to get my head around it. Short and long context. What is the difference?
So if you see Llama 2 or the other models, so they were just fixed to function level or file level understanding of prompts, right? I mean, so which will not understand longer prompts. In the synthesis they were doing. So this long input context, their vision was to unlock repository level reasoning. Okay, so it's not just file level or function level. So they want to unlock complete repository level understanding. Because that's where they have used long input contexts.
How long can the input prompt be?
How long? See, they have mentioned that the context length previously was 4096, but here we can extend up to 100K tokens.
Okay, for 4K context length versus 100K context length. Okay.
Yeah. They have trained specifically 16,000, like 300 around tokens for the context, but they have mentioned that the stability was still 100K tokens in terms of perplexity, which I was showing here, right? So that's the major advantage. And also, the parameters were rope, which is a different paper on positional understanding, positional embedding. So that's the advantage of long input context. Thank you. Okay. Any other questions before I move?
Comparison with GPT-4, is Llama 2 competing with GPT-4 or it's still lagging?
I'll come here. So GPT-4 is 67 based on human eval, but the code Llama is 53 with 34 billion model. But it has definitely outperformed GPT 3.5.
I see. So still not there with GPT-4. Okay.
Not at GPT-4. Even 3.5 is good.
Hmm. This human eval, what does it mean? Like humans are evaluating its sensors. Huh?
No, these are different big benchmarks. So when you train your LLMs, so there are a lot of benchmarks which you evaluate on to publish it, right? So there is a big bench, there is the stand bench. So there are a lot of benchmarks. So human eval is one of that benchmark which evaluates this.
So will we be like, so you are saying like couldn't get it surely. So we can like when we are fine tuning code Llama, we can define our own context length. Like if they have trained on 16K and we can take it up to 100,000, 1 lakh tokens.
Yes, you can adjust that.
Okay, so like it would be performing like Claude and all.
Yeah, you can adjust the memory according to 100K. I mean, it'll cost you RAM when you implement on your local, but that's possible.
Okay, and so like the code Llama base is like 7B and 13B, all right? Like so similar to Llama 2, and so the base architecture is changed, or they have just changed the fine tuning data set.
It's just a fine tuning they have changed. The Llama 2 is the base model. As I was
Okay.
showing here, so Llama 2 is a foundational model, and on that they have done this fine tuning with infilling code and Python code and norm context tuning and injection fine tuning. So they have used it's a fine tuning. It's fine tuned model. It's not from scratch. So that's what I was mentioning. Like the star coder and all were trained from scratch using code, while this code Llama and Codex also is trained on. It's fine tuned on bigger models.
Okay, that's cool. So like if I have some like for a project, I have requirement like it would be a question answer only, like retrieval augmented generation is there, but like it is more dependent on code. So like should I go ahead with code Llama or like Llama instruct?
What is your question
So
answering?
basically, so like my requirement is like for an internal project, like there is a huge repository of documents, like what all projects have been done in the company, right? So for that, I am making a question answer bot over it.
Right.
Like it is most of them are if tech based, then I should use code Llama, right?
Right. Yeah, if it is more of tech based, because in this 500 billion, 85% of the data is all code and code related data, right? So you have to use, if it's more of in the code or technical code terms, then you have to use code Llama. Otherwise, Llama 2 is fine.
Okay, cool. Thank you.
Right. So it's basically specific. I mean, there are two fine tuning, right? Like, we have specific task fine tuning. So it's similar to that, but they have also added in such a fashion that it will not just work for code, but also work for generic tasks. Okay, but majorly code.
Okay, thank you.
Right. Okay, so yeah. So
I might have can we fine tune it further? You might have covered it. Can we fine tune it further with a custom data set?
Yeah, we can do specific
Okay.
fine tuning a lot. So that this is Snowflake's results, on text to SQL model. So they have used a direct model, out of boxes direct model, which is Code Llama, 34 billion, 7 billion model, and they have fine tuned the Code Llama and Code Llama model. So that is fine tuned result. So they have mentioned that these are the results. So you can definitely see the results here, which say that I mean, Code Llama has outperformed Llama 2 at least by like 11 to 30% accuracy points on text to SQL tasks. and they come very close to GPT-4 performance as well, they say. Okay, so you can see the results here on direct usage and even fine-tuned usage. So fine-tuned is quite better, obviously.
Yeah, Sai, one more question. Does it support RAG?
Sorry.
It supports RAG, right? Retrieval augmented generation. So let's say I have my PDF, because in Imagine GPT knowledge base miner, we are able to upload PDF, create embedding, and then use that semantic search context to ping the GPT API. So this also we can do RAG with Llama 2 or Code Llama, right?
Yeah, that you can do with text. I mean, basically, you're augmenting the prompts which you're feeding to LLM with external information. That's possible with Code Llama.
Okay.
Okay, so that's about the performance and even the results on fine tuning with text to SQL. So these are papers I've used, and let's go to some play around. So let me reshare my screen with this. So I'm using Perplexity Labs, so to help you, work on this. So this is basically they have all the different models here. So here they have Code Llama 34B instruct model, which they have deployed. So I'll be using this model, and so let us try a few questions and see how actually it's giving. So let me say that. So write a function or calculator that takes two numbers in an operation to return the result of operation. Okay, so basically a simple calculator. So this is what I'm getting. So you see instruct. So the advantage of instruct is just this, it not only gives the answer but also explains the answer very big, very wonderful. Okay, and I've tried this, I mean, the same code on notebook. It's good. It's good. Let me try one more. Let me try Fibonacci series. This so this gave me the Fibonacci series, and it has implemented recursion. If I see, so I say and do it without recursion. So give me the recursion as well. So and giving the explanation for the answer as well. Okay, so for the basic questions, it was quite good. Let me try one more. So I'm saying to remove duplicates in a list with preserving the order. Okay, this is the question. Remove duplicates, the function, and preserve the order. So they would just remove the duplicates and give me the answer as well. So I'll say try list comprehension. So it has given me the list comprehension method as well. L.compare. So this also works. So simple tasks are very good. So I tried one more. So which is complex one. Give me Roman 2 number. From Roman letter to integer, that's what I'm asking. So yeah, so it has given this function. Yeah, so this is also good. So I've tried on basic questions, it was still working, but for complex questions, it fails a lot sometimes. So maybe, but on reprompting to adjust the answer, it works. So that's what I've observed. Maybe uh, you have any question to ask or something? Someone wants to ask a
I
good.
think the magic is in prompt, right? So
Yeah. There was prompt.
so you have the prompt engineering itself is a big area. How you formulate your prompt and positive, negative, right? So that can change the behavior.
Right. Yes.
Anybody else has a question? I think somebody wanted you to write a code to fine tune Llama or code Llama. How to write code to fine tune code Llama? That's the prompt.
Okay. No, write a code to fine.
Write a script to fine tune code Llama.
Okay. Yeah. I mean, this is nothing but the GitHub information, so you can directly use it. So maybe it's written the same thing.
You don't have to write code Llama, you just have to write Llama, because code Llama is something maybe it doesn't know. You can just write a simple prompt saying write a code to fine tune Llama. It's going to write it. I mean, I just tried it, gave a big code. I don't know why it's not working for you. It just depends on the prompt. The perfect prompt which I use is write code for fine tuning Llama.
Okay.
I think write code, not script. Yeah.
I mean, prompting is little prompting also.
Doing the same thing.
No, I think there is an issue.
Yeah. Okay. It's giving
Oh,
more.
it's working.
Mhm.
It worked for me very good.
Since transformers and sentence transformers has came, like it is quite easy now. So it is almost correct only. Like, can you write tell it to write a code which is highly optimized and can be to train Llama, to train Llama 2,
Fine tune Llama 2, right?
fine tune Llama 2 on a 16 GB GPU.
16 CPU.
16 GB GPU.
16 GB CPU. Yeah. So this is the answer. The same answer. Maybe just that it has given this. Yeah. I mean, it's also, the paper they mentioned that if you have a smaller, they initially used smaller learning rate, so it was not good. But they used the same learning rate as Llama 2, so it worked well. Anyway, I thought to mention because this came out. Okay.
The AI community has been working very hard to make ourselves jobless.
Okay. So yeah, let's go to collab. Maybe we are also losing a lot of time. I'll go to collab and let us try something else. Okay. In between, I was just setting up the collab, but I think it's done. What happened? Okay, it's running. So I can't use it when I run it. Yeah. So I'm using transformers to do the same. So I thought I'll show some examples on, because Code Llama promises that it will work well on code completion and also filling in between the context. So I tried this too. Maybe I'll show this too. So this I've cloned it, and yeah. So I think this will take some time again. But anyways, I think this will take some time, but I can show the output which I ran in between. Yeah, so I've asked. Sorry?
You're using this pro version of the collab, because it's not going to work in normal, right?
No, I'm not using Pro. I'm just using normal collab with just the GPU T4. I mean, correct runtime.
Okay.
T4.
You might be using the context version.
Yeah, quantized
Yeah.
version of
Yes,
your
I'm using instruct here, and 7B instruct.
Okay.
So that's why I was able to run it also. Anyways, so the first question I asked was, I gave an input prompt, which is the code, and it has filled it rightly, actually, with the socket code. Okay. And it also added additional backoff time of for this. But anyway, this was good. And I also gave this prompt import argparse and a string to return on this fashion. So it has completed the code with all the argparse arguments. What is required, because we need string, and the argument was string and string to reverse. So it is understood that code is to reverse. I didn't write anywhere reverse here. I just wrote a main function, and I said that it has to print the reverse of it, right? So it has understood that I'm using argparse here. So it has given the description on itself that it is to reverse a string. It has given the argument string, and also type is also string, and it has said that it is the help is to reverse a string to reverse. Okay, and then the result. So it is understanding what code I wrote, even without any words or something, right? And what to fill it. So this is the second completion I've tried. So it was good. And this is the third one for filling the missing code. So I wrote a code, remove non-ASCII and return result. So this is the fill. So I set it to fill it. So it has filled it. So these are the comments, and then it has started with result and the result, and it also gave me a test script to check it, right? So it was able to fill, which is a good thing. This filling was not very good in any other model which they have done it in filling, right? So they've trained it. So I also tried the instruct with role user inputs. So it has given me in this fashion. So in bash, how do I list all text? So it has given me the similar fashion. Okay, maybe this is done. Yeah, this is done. So let me run it and let us fastly check out. So I gave a question, write a function that detects a pattern that matches the style of this format. So this is a prompt, and I'm running this. So this also takes time.
Yeah, feel free to ask questions, folks. You can speak up.
So I had a query. So what we are trying to attempt in Colab, are we fine-tuning the model?
No, we are not finding the model. So maybe I should have done this. So I just taken the model from Hugging Face, and then I'm trying to run it using different prompts. That's all. I'm just testing it out, and I'm testing in a fashion because it claims it can fill the text, it can do code completion, it can even give SQL queries, it can even do instructions. So I am trying different fashions in the same fashion, in the same method, just basically checking what they have mentioned. So fine tuning we are not doing here. Maybe that will take a higher machine and also more time to do it. Okay, so we'll not be doing fine tuning. Obviously, maybe we'll cover in different sessions of fine tuning. So here I'm just helping you out how to do this prompting. That's all.
Okay, so here there's a specific syntax to do the prompting as opposed to, let's say, ChatGPT or Bard.
Syntax in the sense.
So you're giving it, right? This is a system. This is
Yeah,
the
it is.
user.
Yeah, it is just the generic prompt how we use in ChatGPT. Similar fashion, the prompt, user prompt, or maybe system prompt, or maybe generic information for the task, or maybe you can even try a few short, like with examples or something. Right?
Okay.
So that also works. So I think this has run. So write a function that it has a pattern. So it has written the code to detect the pattern. Okay, let us check this. It is 2, 3, and 4. Yeah, it is 2, 3, and 4 words, digits, and find all. Yeah, it's correct. It will work, and it has used regex, which we haven't mentioned it also. Yeah, we haven't mentioned regex, so it has used regex. Okay, and this is a different prompt. I gave just a prompt with input code. That's all. I just wrote import statement and a definition for a function. Okay, so it has filled it and gave me a result, and it is also correct. It is basically socket connection, and it is creating connection with the socket and returning false if it is not. So it knows that the connection host is 80. I mean in general, and also the error is 9. So it knows that this information is prevalent, right? So it is able to do that. Thirdly, I have tried this. I gave an import argparse to capture the arguments from the external file. From command line. So I have given the main function, and the print was just reversing a string. So I have not written reverse a string. So when I run it, so it was able to give the result accordingly. So maybe let us show this also. So I hope you are understanding. I'm trying different prompts. This is the first prompt. This is the second prompt. This is the third prompt. And I'm explaining like how different ways it is behaving. So it has understood that it is reversing a string. So that's why it gave description as reverse a string. It has also understood that it's argparse, though I have to give arguments from external command line, right? So it has given the argument as a string, and it knows that the input is string and it is type string, and then give the output. And then it says the second step is to run this file python reverse string.py, and string is hello. And when you print it, it will say the input is hello, output is the reverse of it. Right? So that is an advantage in unstruct, which can detail the information a bit more. And thirdly, I have said it this time not to complete the text, but fill the text in between. Right? So I wrote a function, and I gave the result also, I gave the input also, I just said to fill it. And it was able to fill it successfully. Okay. And it gave me test script as well to check it. And yeah, maybe let me try this one. I tried this also. So I said they are a powerful text to SQL model. Your job is to answer questions about database. You are given the question and context regarding one or more tables. So I gave, you must output the SQL query that answers the question. So input is which class has a frequency megahertz larger than 91.5 and the city of license of and is Nebraska. So I said the context is it has a table, the create table name, and it has the class, frequency, city of license details. So the response when I ran it, it gave me the input, the context, and the response, which is also correct. I set him to select the class which has frequency larger than 91.5 and city of license highness. So select class from this table, and the frequency is greater than 91.5 and city of license is highness. Okay, so but it has missed Nebraska. If Nebraska would be there. This could have changed. Maybe you should have given Kama, Nebraska, something. Okay, so I've tried different methods, so it works good. I can share this notebook if you want to play around. So any questions?
How to download this model and things? We'll talk about it.
To download this model, you have to request, you have to go to ai.meta.com and request, give your email ID and request that you want to download the model and try it out. Okay, so then it'll reply, you'll get a reply in the mail, and in that reply you'll get a link, a custom link for your mail ID. So now you keep this link saved, go to GitHub repository, and you will find a Code Llama GitHub repository. You'll find a file called download.sh. It's a bash. You have to run the bash file. So run the bash download .sh file. So then you will, while you run it, it'll ask the link which you got in the email, the custom link. So paste that link and give the model which you want. It'll ask which model to download. So you can mention the model which you want to download, and then it will download it.
Okay, so what's the site website you told?
ai.meta.com, meta.com, ai.meta. Okay. Any other questions, guys?
So I think a lot of folks are asking if you can share the Colab notebook link. That's up to you if you like to share, Sai.
No, I can share it. I'll share it maybe in the group. That's what.
Yeah, you can put it in the India group or here, whatever you prefer.
Sure.
I also had a query. So can we not download from Hugging Face as well? We have to go to ai. What was that? Meta.com.
No. If you want to run it separately on a TPU and do that, like custom fine tuning and all that, I mean, it'll work. Otherwise, Hugging Face is sufficient. I did in Hugging Face only, right?
Okay.
So initially in the class, in the session I was mentioning starting, right? So how you can get the model and apply for the next steps for the GitHub repository. So for that you can use the steps I mentioned. Otherwise, Hugging Face is fine.
Okay. Thank you.
But here you just get H5 model. In Hugging Face you get H5 model only, right? But in that link which you download, you'll get the tokenizer and everything separately. You can get it all.
Mhm.
Okay, so to conclude, from Hugging Face, I can only get read-only model, but from AI, I can get read-write model. I can do fine-tuning on that.
Correct. You can apply more on that.
Okay.
Yeah, the Freedom GPT which we developed for our Austin client was based on a Llama 2 library available in Hugging Face. So I'm assuming Code Llama is also available as a baseline version in Hugging Face. That's my assumption.
Yeah, it's available. You have all the versions: 7B, Instruct, 34B.
But I can download those from Hugging Face and fine tune it. So why you said you can only fine tune the one you get from Meta?
No, you can fine tune from Hugging Face also. That's not a problem.
Okay. Any other questions, folks?
So Code Llama means which all languages of this is currently supporting, or means I think I saw the SQL and Python, right? But
I think I didn't hear you. Your voice was not really clear.
yeah. So Code Llama, which all languages and you think it supports, right? Is it Python, SQL, and anything else, or means
So what language will this model support? That's what is the question.
yeah.
So I was mentioning right in the starting. So you have Python, C++, you have Java, PHP, TypeScript, C#, Bash. All these
SQL, right? SQL, right?
SQL, obviously. SQL. All these will be supported in major. And Python is most majorly.
Okay, thanks.
Okay, great. Any other questions, folks? So quite a detailed, presentation by Sai here. Any other questions before we close today? Okay, so in that case, thanks, Sai. Very well done. Excellent job. And both the PPT and the code demonstration were quite excellent. And people are appreciating it. So thank you for your hard work and a slick presentation. And we'll definitely look to new, sessions from you future. Omar, you have a question today? Okay, maybe not. So, all right. So a lot of, hand claps are coming, as you can see. That's great. Folks, any other questions for today? And as I said in the WhatsApp group, we are hiring. We need an expert GenAI developer at the junior level in Salesstrat for helping us with our product development roadmap, which is Imagine GPT. So we are planning to, we have GPT API on Imagine GPT. We are introducing Llama 2 and for all of our apps. And our community folks like Sai and many others help us develop our products in webinars. So you too can participate and just contact me offline. Sai, are we done or you have more comments?
I am done. Thank you, everyone.
Okay, so, sounds great. Thank you so much, Sai. Excellent presentation. And have a good one, folks. We'll see you in our upcoming sessions. By the way, don't forget to join our LLM Jam next weekend if you are in Bangalore in person in WeWork Bellandur. Okay.